Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today, I have one topic to discuss in my weekly screencast: how a low-mass supernova triggered the solar system. Now, for once, I actually agree with something that was in Science Daily. And that's what it says here. The title of this piece in Science Daily is "Low Mass Supernova May Have Triggered Formation of Our Solar System." This comes from the University of Minnesota College of Science and Engineering. So, now, however, they still don't have it quite right, but at least they're closer than in some previous theories. So it says here, about 4.6 billion years ago, a cloud of gas and dust that eventually formed our solar system was disturbed. The ensuing gravitational collapse formed the proto-sun with the surrounding disk where the planets were born. That cloud might be somewhere to some region in this much larger complex of gas and dust about 4,500 light years away in the constellation Cygnus, observed by NASA's Spitzer telescope. Well, that's not exactly how it happened. Let's just see. Let's scroll down here. What do we have? So this, make sure I got this guy's name right, Kien. So, School of Physics and Astronomy Professor Yang Zong Kien. He's an expert on the formation of nuclei and supernovae. His previous research is focused on the various mechanisms by which this occurs in supernovae of different masses, so on and so forth. So it says here, Kien and his collaborators decided to test whether a low-mass supernova about 12 times heavier than our Sun could explain the meteoritic record. They began their research by examining beryllium-10, a short-lived nucleus has 4 protons, according to conventional theory, and 6 neutrons, according to conventional theory. And it says that this is widely distributed in meteorites. So he's using different models, and he says that this particular isotope can be produced by neutrino spallation in supernovae of both low and high masses. However, only a low-mass supernova triggering the formation of solar systems is consistent with the overall meteoritic record. Well, anyway, it's closer than just having a dust cloud collapse, forming the sun and the stars. According to the reciprocal system, which has been in print since 1959, there was a single star prior to our sun. It went supernova after about 10 billion years of existence and created both the sun and the planets and minor bodies in the process. Now, the supernova had ejecta in space, which later condensed back into our sun, our current sun, and there was an expansion in time, which is a contraction in space, which created the planets rather than a white dwarf star. So, our universe is way older than 13.7 billion years because our sun is about 4.6 billion years now, and the previous sun probably lasted around 10 billion years. So, actually, according to the reciprocal system, the minimum age of the universe would have to be around 100 billion years because the two halves of the universe to be in equilibrium will take about 50 billion years. And so for a complete cycle, it would be 2 times that, or 100 billion years to make sure that everything is in total equilibrium. So anyway, well, that's it for today. So at least those researchers have come a little bit closer to the reciprocal system point of view. Okay, now, If you want the simplest possible treatment of the theory, please obtain my work. The Unmysterious Universe has all the concepts, many diagrams, very little in the way of mathematics. The purpose of the work was to introduce the theory and make sure the concepts are correct. Now, if you do want all the mathematics, then please obtain my magnum opus, which is a software ebook, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF, 711 slides in the PowerPoint file. Thousands of equations, numerous tables, diagrams. It'll keep you busy for months. Now, when you get through with that, you might be ready then for the 2 database modules, which make it easy to apply the theory to your scientific or engineering practice. Reciprocal System Microcosmos database covers photons, subatoms, atoms, compounds, and alloys. Also covers cosmic atoms. So that's the whole microcosmos. Numerous graphs, you can print the properties as a function of temperature, pressure, or whatever. So extremely comprehensive. There's nothing like it in the world, especially there's nothing like this in quantum mechanics, where you can't really calculate any serious property of matter. All right, then the Reciprocal System Macrocosmos database. This covers the astronomical world, the universe as a whole, galaxy clusters, galaxy star clusters, stars, planets, moons, minor bodies like asteroids and comets, nebulae, and voids. Again, very comprehensive, great graph capability with it. So those 2 database modules together form take a very comprehensive look at physical science, applied physical science, computational physical science especially. Now, Dewey B. Larson was also an economics theorist, and I've made his work in economics also fully computational. That's in my software, commercial software called Optimal Economist, an implementation of Larsonian econophysics. It covers the microeconomics of individuals and businesses and business sectors, and then the macroeconomics of entire countries. So that work is also very comprehensive within its field. The software makes it very easy to apply the theory to the actual economic problems of today. Okay, that wraps it up. Again, please study the reciprocal system and prove it for yourself. Thanks for your attention.